For centuries, it was just a tiny dot in the sky. Then, through our telescopes, a fuzzy orange ball. But Saturn's largest moon, Titan, has turned out to be one of the most fascinating and, well, strangely familiar worlds in our entire solar system. So let's dive into what makes this distant moon such a bizarre, frozen twin to our own planet.
You know, before the incredible Cassini mission showed up, Titan was a total mystery. Its surface was completely hidden under this thick, orange, nitrogen-rich haze. We knew it was big, it's larger than the planet Mercury, but what was actually down there? That was one of the biggest questions in planetary science.
And then Cassini arrived. It was equipped with powerful radar that could finally slice right through that atmospheric veil. And what it found was absolutely shocking. It wasn't just some boring, cratered block of ice. No, it was a world that looked, in so many ways, just like our own.
And the sheer variety of what Cassini found is just astounding. It wasn't just one or two familiar things. It was the whole shebang. Vast fields of dunes, complex river networks, massive lakes and seas, mountains, and even what looked like volcanoes. Get this, after Earth, Titan has the most geologically diverse and complex surface in the entire solar system, period.
Okay, just look at this. This isn't a coastline in Norway or California. This is Titan. You can clearly make out bays, cliffs, and river estuaries emptying into a huge sea. The shapes are so familiar, but the ingredients? Well, that's where things get completely alien.
So, if the landscapes look so much like home, what are they made of? It's way too cold for liquid water to be flowing on the surface. The answer, and this is really the key to understanding Titan, is liquid methane and ethane. So Titan basically has its own version of a water cycle, but it's all based on hydrocarbons. Methane evaporates from the seas, it forms clouds, and then it rains back down. This methane rain is what carves out those river channels and keeps the lakes full. It's an entire weather system just, operating at a bone-chilling minus 179 degrees Celsius. And we're not talking about small puddles. Cassini's measurements revealed a truly staggering amount of liquid hydrocarbons on the surface, at least 70,000 cubic kilometers. To put that in perspective, that is hundreds of times more than all of Earth's proven oil and natural gas reserves combined. It's just drenched in the stuff.
For most of its mission, Cassini noticed something kinda odd. These huge seas were almost perfectly smooth, like glass smooth. We're talking deviations of just millimeters. It suggested a world with almost no wind at all, just eerily calm and still.
But then, the seasons changed. As spring arrived in Titan's northern hemisphere, so did the wind. And for the very first time, Cassini detected waves, actual waves rippling across the surfaces of these alien seas. It was absolute proof that Titan is not a static world. It has dynamic weather and seasons, just like us.
But the composition of these seas held another surprise. Scientists expected them to be a rich soup of both methane and ethane, since ethane is constantly being made up in the atmosphere. But what Cassini found was that they are overwhelmingly made of methane. This created a brand new puzzle. Where did all the ethane go? It's a major mystery that future missions are going to have to solve.
All right, so let's look up from the surface, because Titan's atmosphere is just as complicated. It's basically a giant chemical factory, where sunlight and particles from Saturn's magnetosphere are constantly breaking down methane and nitrogen to create this whole zoo of complex organic molecules.
The engine driving all of this is a massive, single circulation cell that stretches from pole to pole. This creates an enormous polar vortex in whichever hemisphere is having winter, and it acts like a giant atmospheric container, trapping all these unique chemicals and creating some really extreme conditions.
And when I say extreme, I mean it. Winds inside this winter vortex can hit 200 meters per second. Sinking air creates this bizarre hotspot way up high in the stratosphere, while the levels below get incredibly cold. This whole process concentrates all sorts of exotic chemicals that you just can't find anywhere else on Titan.
And here is a perfect example of how Titan just keeps surprising us. After the 2009 equinox, all the models predicted the South Pole would gradually warm up at high altitudes as it headed into its own winter. Instead, it did the exact opposite. It cooled down rapidly and dramatically. This allowed these strange ice clouds, including hydrogen cyanide ice, to form. It just showed us how little we still understand about its complex climate.
So we have an Earth-like surface and a bizarrely active atmosphere.
But Cassini's biggest discovery wasn't on the surface or in the sky. No, it was buried deep, deep down. After everything we've seen on the surface and in the sky, you just have to ask, what else could this world possibly be hiding underneath that thick frozen shell?
Well, scientists found the answer by tracking Cassini's path with unbelievable precision. They measured these tiny wobbles in Titan's gravity field, and they watched how the moon literally flexed and squeezed as it orbited Saturn. And the only way to explain all that data was if the icy crust was floating on top of something liquid.
And that is the biggest secret of all. Beneath its icy shell, Titan is hiding a massive global ocean of liquid water. The data even suggests this ocean is probably salty, which would make it denser than pure water. An ocean of water on a world with rivers of methane. Just wow.
Cassini completely rewrote the book on Titan, transforming it from some mysterious orange orb into a complex, active world. But you know how it is. In answering the old questions, it raised so many new ones.
Ultimately, Cassini showed us that Titan is a world of distinct, fascinating layers. You've got a surface that looks like home, but is carved by an alien liquid. You've got a complex atmosphere that's a factory for organic molecules. And then you've got a hidden ocean of water, the very thing we always associate with life. It's like all the ingredients are there.
And that leaves us with the ultimate question, doesn't it? In this incredible environment, where organic molecules rain from the sky onto a dynamic surface, which itself sits on top of a vast water ocean, what kind of chemistry, or maybe something more, could be unfolding? That is the mystery that's going to drive us back to this bizarre, beautiful twin of our own world.